Okay, in this video we will go very quickly over radicals or radical expressions. Okay, so let's start very quickly. What is the nth root of a? How do we define the nth root of a? Nth root of a is equal to b if and only if b times b times b times b, that's n times, right, which can be written as an b to exponent n is equal to a. Okay, for example, the fifth root of 32 is equal to 2 because 32 is equal to 2 to the power of 5, or that's 2 times 2 times 2 times 2 times 2. So we have 5 of these, right? 5 times. Okay, or if you have square root of 144, if the number here it's not written, that means that we're talking about the square root. Okay, so this is equal to 12 because 144 is equal to 12 squared, or that's 12 times 12. Now the first thing that we have to right away deal with is the fact that 144 is also equal to negative 12 squared. Okay, because negative 12 times negative 12, negative times negative becomes positive, and then you have 12 times 12 is equal to 144. Does this mean that square root of 144 is equal to negative 12 as well? Well, that's no. Okay, so the square root, and as a matter of fact every even root, indicates a non-negative square root. Okay, and this is going to become slightly more clear once we talk about functions. Okay, so for any number, square root of x squared is equal not to x but rather to absolute value of x. Okay, or we can even generalize this: for every even root n, x to the power of n is equal to absolute value of x when n is even. Okay, and the same definition, the nth root of x to the power of n is simply equal to n when n is odd. Okay, so let's see a few examples. Okay, so if you have square root of, or let's say fourth root of 81, that's equal to the fourth root of 3 to the power of 4, and by the definition that we wrote, this is simply equal to 3, right? Fourth root of negative 81 simply does not exist. Why? Because you cannot find the number such that multiplied by itself 4 times will give you a negative number. If that number is positive, multiplied by itself 4 times will give you a positive number, so you cannot produce negative 81. If you take a negative number and you multiply it by itself 4 times, again you'll get a positive number. So even root of a negative number doesn't exist, but an odd root of a negative number indeed exists. Third root of negative 27 is equal to the third root of negative 3 cubed, and by the definition that we wrote on the previous example, is equal to negative 3. Okay, so one more time, nth root of x to the power of n. This is very important for calculus. You'll see this over and over, so please be careful. Absolute value of x if n is even, and just x if n is odd. Okay, so here I just want to give you two properties of radicals, right? If you have nth root of a times nth root of b. This can be written as nth root of ab, and similarly nth root of a over nth root of b is equal to nth root of a over b. Okay, so let's do an example. Simplify the following example. Fifth root of negative 32a to the power of 7 times the fourth root of a to the power of 8 times b to the power of 4. Okay, let's go slowly here. Fifth root of negative 32 is negative 2 to the power of 5. Okay, by properties of exponents, a to the power 7 is a to the power 5 times x squared. When we multiply exponents, right, the exponents, we add the exponents of 5 plus 2 is 7. That means that a to the power 5 times a to the power 2 is a to the power 7. Times the fourth root of a squared to the power of 4. When we raise exponents to another exponent, then this expression is equal to a to the power 2 times 4. 2 times 4 is 8 times b to the power of 4. Okay, so fifth root, odd root of x to the power 5 is just x. So fifth root of negative 2 to the power 5 is just negative 2. Okay, similarly for a, no matter what a is, whether it's positive or negative, fifth root of a to the power 5 is just a. And then I'm left with fifth root of a squared, which cannot be simplified any further. Times, now I have even root. Even root of x, let's think about this whole thing as x, right? A squared is x. So fourth root of x to the power of 4 is absolute value of x. So let's just write that down, absolute value of a squared times b, fourth root of b to the power of 4 is absolute value of b. Okay, we're almost done. Is that we just have to notice that what is absolute value, right? The definition of absolute value is that absolute value of x is equal to x if x is non-negative, and negative x if x is less than 0, strictly less than 0. That's the definition of absolute value of x. Okay, so we don't know what are these values of a and b, right? Which means I cannot drop the absolute value right here. Absolute value of b, I don't know whether it's b or negative b, because I don't know the value of b. But a squared is always positive. No matter if a is positive or negative, square that, a squared is going to be positive. So absolute value of something that's positive, absolute value of x, when x is positive, is simply x. So that means that this absolute value can be simplified. This is negative 2a times a times absolute value of b times the fifth root of a squared. Finally, this is negative 2a squared times the absolute value of b times the fifth root of a squared. Okay, let's do another problem. Again, the question is the same. Simplify. Square root of 1 plus x over square root of 1 minus x squared, and then the whole thing squared. Okay? So this is square root of 1 plus, when you have a over b squared, that's equal to a squared over b squared. Okay, so I'm applying this property for my expression right here, and I have x squared over square root of 1 minus x squared and then squared, which is equal to square root of 1 plus x squared over square root of a squared is just a, so we have 1 minus x squared. Very soon, when we're going to talk about functions, we will see here that x can only take these values, right? This expression can be defined as long as x is between, this is the same as saying that x is between -1 and 1. Okay, strictly greater than -1 and strictly less than -1. Why? Because if it's any other values less than -1 or greater than 1, then this difference here under the square root is going to be negative, and we cannot take square root of a negative number. And why it cannot be neither equal to -1 nor equal to 1? Because in that case this difference is going to be 0 and we cannot divide by 0. Okay, but this thing is going to be more clear once we talk about the domain of a function. Okay, now what do we have to do? We have to bring the expression under the square root under common denominator. That's 1 minus x squared, which means that 1 is going to be expressed as 1 minus x squared over 1 minus x squared. This is our 1. And now you can either write plus x squared over 1 minus x squared, or you can skip this step by just writing 1 minus x squared plus x squared over 1 minus x squared. Okay, and now we cancel the only thing that can be cancelled, then you have square root of 1 over 1 minus x squared. Now we learned that square root of 1 is 1 over square root of 1 minus x squared. Okay, please don't make the following mistake. Okay, this is not equal, so never get trapped in thinking that square root of a squared minus b squared is equal to, as a matter of fact, plus or minus b. Okay, please never do that mistake. Okay, so this is the right answer.